Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who supports us on Patreon. Your contributions help to make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at www.podcastinit.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your app or experimenting with something that you hear about on the show. You can visit the site at www.podcastinit.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. To help other people find the show, please leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host, as usual, is Tobias Macy, and today I'm interviewing Stefan van der Walt and Juan Nunez-Iglesias about Scikit-Image. So could you guys introduce yourselves? How about you start first, Stefan?
Hi, everyone. Stefan here. I'm the founder of Scikit-Image, and I'm currently employed as a researcher at the Berkeley Institute for Data Science.
And Juan, how about you?
I'm Juan Nunez-Iglesias, and I'm employed as a researcher at the University of Melbourne. And before that, I was at Janelia Research Campus in the US, which is where I got started with Scikit-Image, analyzing neuronal images.
And going in the same order again, how did you first get introduced to Python?
So, I guess I've always been dabbling in all sorts of programming languages at school, and I used Python way back for organizing my MP3 collection. I really started learning it in all seriousness at a holiday job at a tech company, and that's also where I was exposed for the first time to extreme programming, for example. Scientific programming, I started doing sort of around 2001. I worked on the Octave project for a long time, and I was trying to switch our team over to an open source language for science for a long time. That didn't happen. But then my study advisor in Boulder met a young postdoc, and he brought him to South Africa to teach a Python course. The team got very excited about Python. They wanted to switch, and I was just too delighted to help him switch to an open source project. So all my attention moved from Octave onto Python. And that postdoc, by the way, was Fernando Perez.
I interviewed Fernando a while ago to talk about IPython, so it's funny how these things come full circle.
Yeah.
And Juan, how about you? Do you remember how you first got introduced to Python?
I don't remember getting introduced to it. I remember so I started out as a biologist, and I took a couple of electives at university to learn C and Haskell, and that was that. I was, off to do biology, and then I needed to do some data analysis, and I started using C++ for that, because that's what I learned. And at some point, I switched to Python, and I don't remember that decision, but obviously it was a good one. Yeah, and so I finished my PhD in Python code with a bit of R for data analysis and so on. And then in my postdoc, I moved to a lab that was using only MATLAB, and I learned that, and that was fine. But eventually, I wanted to do some more general stuff that MATLAB wasn't so good at, such as working with graphs. And so I just ported the whole pipeline to Python, and that was this big, huge effort, which again paid off. So yeah, I kind of discovered Python twice, and the second time it stuck.
So for anybody who isn't already familiar with it, could you guys give a brief overview of what Scikit-Image is and how the project first got started?
Yeah, so Scikit-Image started off as a collection of image processing snippets. Early on, I wrote a lot of code for my PhD, implement a lot of algorithms, and people would ask on the mailing list, does anyone have anything that can do X or Y? So I would email the code snippets, and lots of other people did that too. And eventually it just became clear that, we repeatedly sent the same code to the list over and over, so we should just package all of that up. Initially, the goal was sort of to fully duplicate or re-implement the MATLAB image processing toolbox. And, we even had a little table of compatibility to sort of make sure that we have all the right features. That turned out to be a rather tedious process. The moment we moved away from that and decided we're rather just going to build a, Pythonic library in the style that we really want to, the whole project became a lot more fun. Fairly early on already, we got a fairly big code injection from the Broad Institute's cell profiler team, with whom we still collaborate. So they provided many of the algorithms along with the ones that I and others provided to kickstart the project.
So it seems like the primary focus is for being able to do manipulation of imagery that would be used in the sciences. So I'm wondering if you can do a bit of compare and contrast in terms of the overall project focus between Scikit-Image and other projects like SimpleCV and OpenCV or the Pillow library that people might be familiar with.
Yeah, so these sort of they cover fairly different use cases. In the Python world, we have these marvelous NumPy arrays with their rich semantics for slicing and handling, multidimensional data. So I think often when you work on a C++ library, that's sort of the first layer that needs to be built. We just assume that NumPy is there to start off with. So many of the basic image processing operations can be done with pure NumPy arrays. I think when you look at something like Pillow, which is the replacement for the Python imaging library, that's sort of a very generic mechanism for doing things like cropping, adjusting, rotating. On top of that, or in a sense an extension of that, is SciPy's ND image, which vastly expands Bill for scientific purposes, but it's still a fairly low-level set of tools. And Scikit-Image then sort of tries to build on top of that. OpenCV is more aimed at vision, but it's more similar in scope in a sense to Scikit-Image. And in fact, Scikit-Image used to be an OpenCV wrapper before they had good Python wrappers that could expose NumPy arrays without copying. But as their wrappers improved, we no longer needed to provide those ourselves. So we took that out and we started focusing on implementing useful basic scientific image processing building blocks. The real goal was just to get scientists up and running as quickly as possible. I think I checked recently, and my entire PhD project I could rebuild in a weekend with Scikit-Image. And that's sort of power you get by just, having access to a vast array of basic building blocks. OpenCV itself is great. I think it's phenomenally fast. So it's perfect for processing videos, for example. But I don't think its documentation or its API is very good specifically for Python programmers. And Scikit-Image aims to be very Pythonic, to have good doc strings, and to be easy both to use and to contribute to.
Yeah, when I was doing my senior project for school, I was trying to do some face detection in an image and using OpenCV directly. And yeah, their documentation is rather dense and hard to parse if you're not already familiar with a lot of the mathematical principles at play with image manipulation and image analysis. So fortunately, I happened to chance across Simple CV for that, so it gave me the high level that I needed. But I can definitely see where Scikit-Image would be useful as well for the particular problem domain that it's focused on. So I'm wondering too if you can just draw a comparison between things like the facial detection or simple image recognition stuff that people might use OpenCV for versus the types of use cases and problems that Scikit-Image is more focused on.
Yeah, so there's not 100% overlap, but for this specific problem, we actually had a Google Summer of Code student, Daniil Pakumov. He worked on implementing the Cascade filters. Now, the Cascade filters in OpenCV, I haven't checked over the past month, but last time I checked, they were still an implementation of a patented algorithm. So that's one of the things that we pay very careful attention to. When we make sure that the BSD license that we have, it not only gives people the right to use our code, but we also make sure that if people use the code on the BSD license, they're not going to get themselves into trouble. So we re-implemented the Cascade filters using the same principles as the OpenCV implementation. And that work, we're still in the process of finalizing all of that, but it's available. But I would say, OpenCV, one of the biggest challenges is getting it installed. But that problem is maybe less hard than it used to be. And I think more and more my view is just that we should combine tools as necessary, to get the job done. And we don't see ourselves as direct competition. We're building something that's maybe not perfectly overlapping, but definitely somewhat different in scope.
I would say also it's one of the greatest assets of the scientific Python community that we all seem to have converged on NumPy arrays. And I believe OpenCV these days does take NumPy arrays as input. Do you know if that's right?
Yeah, that's correct.
Yeah, and so it's easier than ever to combine the tools, as Stefan was saying, and just use the tool that you need for the function that you need. And Scikit-Image provides some of those functions, and OpenCV will provide perhaps different ones.
And the Scikit sort of branding, I'm wondering what the relationship is between Scikit-Image and Scikit-Learn or any of the other Scikit packages that other people may have used.
The idea originally was that we would have a namespace that would contain all of these scientific toolboxes. So SciPy is a wonderful set of tools. The problem is, how do you easily experiment with a new algorithm that might not be mature enough to be included in SciPy? How do you, if you feel like you want to fairly rapidly develop something, the SciPy development model is more geared towards slowly moving forward and producing high quality code. So the idea of the Cycads was to give people the opportunity to more rapidly iterate on small, specific pieces of functionality. We originally had it under a single namespace, so it was scikit dot whatever your package was called. There were some technical issues associated with that, so we just became like Scikit-Image, sklearn, etc. And I think those two packages kind of rose out as examples. I mean, I think Scikit-Learn is an exemplary package of how you should develop, document, and publish scientific code. And, we're trying to do something very similar with Scikit-Image. There's an index of Cycads available. So if you go to cycads.appspot.com, you'll get a whole list of everything that's published out there. There's no overarching control or a group trying to exert, any control over how these packages are developed. I think what they share is this very powerful notion of, like Juan mentioned, the NumPy array. We have a set documentation format that completely turned around the way scientific Python is being used. It made it possible for people to learn it in classrooms. The NumPy documentation format was sort of a crucial part of making the scientific Python tools more accessible to newcomers. And that the way we sort of package and format our code, that's sort of what we share between these various Cycads.
And do they all share a common dependency on SciPy? And if so, does that provide an easy way of interoperating between the different Scikit packages?
Again, there's no requirement on how these packages should look. I think most of them depend on NumPy, but anything that plays well inside of the scientific Python ecosystem, which usually implies exposing NumPy arrays. But I guess nowadays it could also mean a pandas data frame or even an X array. Anything would qualify, basically.
Yeah, I mean, I think in the same vein, if you had some package that was something to do with natural language processing, then the set of dependencies might be completely different. But it would still qualify to be a Scikit. I think, as Stefan said, that the documentation format is one of the most important requirements, and that is something that goes above and beyond what even core Python functions provide.
Does it go beyond just using the doc strings in the Python? Do you have additional sort of framework or documentation format that's used to be able to generate the documentation that the Scikit namespace requires?
I also don't know if it actually is a strict requirement, but it should be. If you search for NumPy how to document, that has the source document specifying this, and it does go above and beyond PEP 257, which is the Python's docstring standard. And one of the things that it provides for is that every argument should be annotated with the type and what that argument does. And if you look at some of the core Python function documentations, the docstring is just free-form text that sort of describes what the function does, but there's often not any specification as to what each argument should be, the type of that argument, and the possible options. For example, I think in one of the encoding, if you're trying to save a string in Python, encode a string, it doesn't tell you what the valid encodings are. So in the NumPy docstring standard, you would have to provide all of the possibilities for that.
Yeah, I think this is stated by the Python core team that that's not the primary source of the documentation, that you find on the web in the Sphinx document. So, but because we often spend time in the scientific world inside of an IPython terminal working interactively, my workflow is typically import NumPy and then maybe look around for the function I want to use, look at the docstring, find the input and output parameters, experiment until I find something that does what I want it to, and then copy that or use that in my script, which is perhaps very different from the way or from the workflow that other developers use.
Yeah, I would say actually that's a very good point, that in scientific Python, you spend probably most of your time inside of an IPython terminal. And so it's very handy to just be able to type the function name and a question mark and have that function completely described for you, which might not be as true of core Python functionality.
I also want to mention the Sphinx Gallery, which is the kind of tool that gets developed sort of as a side effect almost of doing something like Scikit-Image or Scikit-Learn. So Scikit-Learn developed the Sphinx Gallery that's now also being used in Scikit-Image, which is the script that basically executes code and then builds a little page with resulting plots and a little pop-out that shows some text. When you click on that, you get a piece of Python that you can paste straight into your terminal or your notebook and execute it and get that exact same image back. So that sort of infrastructure work is often done by one of the Cycads or in collaboration between various Cycads, but then to the benefit of everyone around.
So going back to the Scikit-Image package, one of the things that I was noticing in the documentation is the fact that because it's based on the NumPy ND array, it allows for multi-dimensional images. So I'm curious what some of the ways in which that can manifest as far as exhibiting higher dimensionality than just the standard two-dimensional plot that most people are used to. And what are some of the kinds of operations that Scikit-Image can perform in those kinds of situations?
Yes, so this might be more my domain. And this was one of my, I think this is the contribution that landed me into the Scikit-Image core team, was making one of the algorithms work for 3D images. I still refer back to that pull request because it was just insane trying to get it to work in 3D and trying to get it to pass, different versions of NumPy and so on. So it was Slick, which is a segmentation algorithm. So segmentation is just finding different objects in an image. And the reason I needed things to do in 3D is that in biology, we very often have 3D images. So one example is serial section EM, where you take a slice, in our case of a brain, and you image the top of it, and then you slice it. Sorry, not a slice, a cube of tissue. So you image the top of it, you slice it, and then you image the next thing, kind of like a salami. And so you can then reveal the inner structure of the object in 3 dimensions. And so to find the connections of all the neurons in a brain, this is what you have to do. And then you apply some segmentation algorithm to figure out the limits of all of the neurons and where they're all connected. Another more common form of 3D image that people might be more familiar with would be MRI. So again, that's looking inside someone's brain using magnetic resonance. And so you see those images in movies and so on of people's brains in 3D. There's lots of other images, but because I'm a biologist, this has been a bugbear of mine to try to get as much 3D functionality in Scikit-Image. And when we say ND, what that means is that the algorithm will work equally well for 2D and 3D, and that requires kind of more careful coding. But once you get used to it, it's actually very easy and elegant to write that way. I think there was one thing that I converted recently, which was Hessian filters, and it went from specifying this 2D kernel and then applying the kernel to the image to a very elegant solution where you compute the gradients in 3D, and then for every gradient, you compute a second gradient, and that was the end of that. So I guess what I'm trying to say is that n-dimensional sounds like it's going to be harder, but it often ends up with easier code to read than just two-dimensional code.
So a few years ago, Juan started pushing for better support for n-dimensionality. And I think at the time, I didn't have a very good feeling for the kinds of data on which that, or problems that require that kind of processing. But it's been remarkable for me to see the uptake of Scikit-Image since we've improved in that regard. It was one of the roadmap goals that we set out in our 2014 paper. And the package has had significant increase in 3 and higher dimensional coverage since then. And whenever I speak to people from the biologies or, microscopy is a good example where it's crucial to be able to do that sort of processing. So like Juan mentions, there are a few patterns or paradigms that you learn and then, apply those throughout to get access to that sort of data. And it's been fantastic to see people actually use this and come back and say this is what makes the package useful to them.
Yeah, and one of the other examples of higher dimensionality that was mentioned in the documentation is film or sort of time annotated imagery as well, and using the time as an additional dimension for processing images.
Yes, so I would say that one's a little bit trickier. So one of the issues that you have with higher dimensional images is that typically the third dimension, the distance between pixels in the third dimension is stretched relative to the other two. So for time, that becomes even more complex. How far is one frame from another? Because at least in space, you know that 2 micrometers is a certain ratio different from 0.5 micrometers if you look at the x, y, and the z dimensions. But with time, that conversion isn't as obvious. But certainly there are many algorithms where you could just take time to be a third dimension, have some conversion factor and do it. So for example, if you do segmentation, which again is picking out objects in an image, and you do that in 3D in a video, then that gives you tracking for free. So you can track objects as they move simply as being segments in a 3-dimensional volume. But that may or may not work depending on your frame rate and so on.
And for the implementation of Scikit-Image, what does the internal design look like, and what has been some of the biggest challenges associated with the development process, whether past, present, or future?
I think like with many of these packages, Scikit-Image is a collection of routines that scratch various people's itches, so I wrote this code as part of my PhD. Lots of people, contribute whatever they need to do their work. And it's often easier, well, that's probably not true, but if you want it available in the long run, it's often easier to contribute it back and have other people maintain it than to do it yourself. Of course, there's an initial barrier to contributing. You need to clean up the code, document it, etc. But I think there's a certain, it's quite rewarding to go through that whole process and get it integrated into the package for others to see. You asked about the challenges. I think for a long time, for me, finding time to consistently spend on the project used to be hard. The project used to be done mainly on evenings, weekends, etc. Everyone knows that story. At least for the past 2 years, it's been a lot easier because since I'm working at the Berkeley Institute for Data Science, this is sort of a part of my job. So I've got a lot of freedom in that regard. That said, I'm still very interested in finding a consistent funding source for the project. I would love to have at least a person, a project manager / programmer who can ensure contiguity, sort of who watches PRs to make sure that the project is always moving forward. Not necessarily rapidly, but at least consistently.
Yeah, I want to say an aside from Stefan's talk of the development model and having people contribute what they need. It really is rewarding, and paradoxically, one of the most rewarding moments I had was when I contributed. This was early on in my contributions to Scikit-Image, and I think I made Slick, simple linear iterative clustering, which is a segmentation algorithm. And I made that 3D, and I accidentally broke something of the 2D functionality that I can't remember. But, as soon as we released that next version, someone complained on the internet, some random stranger. And to have someone complain on the internet about your code is actually a really good experience because it means more than one person is using your code, which when you're doing a PhD, it can often seem like you're the only person in the world who cares about what you're doing.
Yeah, and particularly with open source, sometimes the only way to get any feedback about the work that you're doing is if it's broken.
Yeah, that's right. That's absolutely right.
Yeah, I think you read a lot about people who get complaints about the code they write and who have a tough time with users expecting them to do almost like customer support, that sort of thing. I think we've been very lucky. We have a fantastic user community. The Python user community is incredibly friendly overall. And this is one of the things that stood out for me right from the beginning is I spoke to strangers and they would be welcoming. They would take time to teach. They would take time to help you get started on the project. And that welcoming spirit that I experienced back then, I think it's still very much alive and well today in the scientific community, scientific Python community. And of course, we try and keep it alive.
Yeah, I'll say something else about that, which is how I got into Scikit-Image, which is when I first I mentioned that I ported this whole thing of MATLAB pipeline to Python during my postdoc. And then I went to SciPy 2012 to present that work. And at that point, the whole conference was, not the whole conference, but many of the presentations were by people who were the authors of SciPy and IPython. Fernando Perez gave a keynote, which was amazing. And I was just kind of using all of these packages. And when I went to do that presentation, by the way, everyone should go to SciPy because that conference really did change my life. I got an email from Stefan saying, hey, I'm the author of Scikit-Image. Would you like to come to the sprint and do some coding on, tomorrow, I think it was. And so that's how I got my first, that was the time that I did my very first GitHub pull request, made my very first open source contribution. That wasn't just my code put on GitHub. And yeah, that's how I got started. And contributing to open source is something that isn't obvious at the beginning, but then very quickly becomes second nature and is a great way to get your code in more users' hands. And it's extremely rewarding, basically.
So what are some of the most interesting or unexpected uses of the Scikit-Image package that either of you have seen?
Early on, when we first published the paper, one of the citing papers was someone doing satellite reconnaissance, which is obviously far out of either of our wheelhouses, and that was great. More recently, someone commented on the paper about their use. So the paper is on PeerJ, which allows comment, and like many social platforms, is relatively sparse, but we got this one comment from an ecologist who was using minimum cost paths, which is an algorithm that you use in images, for example, to find themes in images if you want to stitch two images together. Stefan has a great tutorial on image stitching that uses it. And they were using it on maps where the cost was essentially like a movement cost, and they were using minimum cost paths as a way to predict species range using some model for how species can move. So again, that's something that's completely different to what I think any of the previous contributors to Scikit-Image would have envisioned, which again is very, very gratifying to see when someone uses your project in a completely different way than you expected.
A fun project I worked on in South Africa was the identification of white sharks. And the researcher there tried to count the number of individuals on the coast. And that was via visual identification. So we used Scikit-Image to sort of detect the edges of the fins, which acted like a fingerprint for each individual. And the other example I thought of was Neil Yeager posted a blog post a while ago showing how when you have a visual identification system, say for unlocking a gate or a door, people can use rubber masks to fool the system. And so he added via Raspberry Pi and some Scikit-Image code a detector that would figure out when is someone using their actual face or a rubber mask to present a certain identity.
That's pretty cool.
Yeah.
I also just want to mention that there are some very interesting novel algorithms being implemented nowadays in deep networks. And it's going to be interesting for us implementing more traditional algorithms to see how this impacts on our work. You know, some of these algorithms, like the purely convolutional networks, we might be able to eventually integrate into Scikit-Image. But, you know, this opens an entirely new frontier of exploration. It's going to be interesting to see how it plays out.
Given the somewhat complicated nature of the algorithms that are in play for doing the different image analysis, do you find any difficulty in attracting contributors to the project?
No, I don't think so. I mean, we just released version 0.13, and we had on the order of, Juan did the release, so he would know, was it 82, 83 people maybe?
Yeah.
So I didn't count how many of those were new contributors, but that's certainly much larger than our standard team of about 10 or 15 people. I still run into researchers who tell me, oh, thanks for the package. We use it on a daily basis. We don't often see those people. They're not all on the mailing list. We're not in active conversation with all of them. In fact, it's quite challenging to figure out who is using the package, what purpose are they using it for. And in a sense, that's also what makes it hard to guide the package and why we rely on contributions to some extent to determine which direction we have to go.
Yeah, if we could find a way to increase user engagement in that way, that would be really good. I mean, as I mentioned, I started out just being a user of Scikit-Image. And it was an amazing change to start contributing and to realize that contributors are just people like you and me. They're not these professional developers who are, completely out of this world and who do this day in, day out. They're people who work on image processing and write the code that they need to do their work. So it would be really great to have more users come forward and say, oh, it would be great if this function did this a little bit different, and we can help them to solve that problem.
Yeah, I think at every scientific Python conference I go to, and we have a sprint, you have this amazing engagement with people who want to do image processing and maybe even want to contribute to the package, but it might just seem a bit intimidating or scary from the outside. And I mean, that's no small wonder. I mean, you need to know a fair variety of tools. You need to understand Git. You need to know, how to write the documentation. You need to understand Python fairly well, know NumPy. So all of these things can be a bit overwhelming. But I think it's one of the most satisfying experiences to sit with people, help them to succeed in implementing what they want to implement. Not only getting their own results, but also contributing what they've done back, whether that is in terms of code or perhaps in terms of just a small patch to the documentation or the installation instructions. Inevitably, that's my most rewarding experience at each SciPy conference.
Yeah, and a couple of things that Juan mentioned are recurring themes in a lot of the conversations I have in terms of the difficulty of getting feedback from users, particularly if they don't have anything necessarily to complain about or bugs to report. And
that it's easy to contribute, easier than you think.
Right, yes. And also the fact that it is easy to put a lot of the people who create different open source packages up on a pedestal and succumb to hero worship. But one of the things that I've learned while doing the podcast is that people in general, regardless of the level at which they contribute, are far more approachable than you may at first assume. And that's been a pleasant surprise in terms of inviting people onto the show and the willingness with which they will come and join and share the work that they've done. And then in terms of the feedback, one of the things that I actually was just thinking about is the possibility of adding an API into the package of, something like Scikit-Image.feedback that would open the user's browser to like a type form survey so that people could voluntarily contribute information about how they're using the package, what their thoughts are on it, things like that. And just using that as maybe a general practice for people who are interested in hearing back from the users.
We've had that discussion a couple of times in Scikit-Image, and it's such a hard balance strike between, annoying the users and trying to get more feedback. And I think the iOS App Store has this debate of like apps bugging you for reviews, and some people have the policy that if they get bugged for a review, they'll leave a 1-star review. So it's, I don't know what the right solution is. I think if Scikit-Image.feedback might work, but there's a catch-22 if everyone has to do it before everyone knows about it.
Right.
Having a feedback mechanism could work very well. I think the one thing we couldn't do in the past that would have helped us to discover the kinds of usages we see is to have some kind of automated, phone home system. We can't do that sort of thing in open source libraries. We would not want to. And I think that's where, commercial packages have a much easier time. So they just do it without caring about the user's privacy. But, there might be a few other opportunities for doing it. I know some people around Bits have been thinking about this problem and, maybe integrating a feedback mechanism into Jupyter or something similar. We just don't have anything like that built right now.
Yeah, I can definitely concur that having projects or products that I use sort of nagging me to leave reviews is generally not the best experience. But if it were just an API call, and particularly given the fact that a lot of the work that people do in Python is done at the terminal and sort of exploring the different APIs available, just having it present may be enough to at least get some people to, out of curiosity, call the API or explore what the API is intended to do, and then end up giving you some information about how they're using the package.
Yeah, the other thing, I think we talked about, most scientists just use an IPython terminal or a Jupyter notebook. If we did adopt a unified feedback mechanism like Scikit-Image.feedback, NumPy.feedback, etc., if only IPython mentions this in their header, which is already there, that might actually get quite a bit of adoption. I just thought of that. I don't know if that's a good idea or not.
I've thought that for packages like this, they might not be enough on Stack Overflow for Scikit-Image, but for something like Pandas, which has a vast API, I think it would be fascinating to analyze all the posts or perhaps all the successful or the accepted answers on Stack Overflow and analyze them for example usage or to see which functions were used. I've been having in the back of my head to like do a version of the Pandas docs where you set the alpha value of the function based on how many times it gets mentioned on Stack Overflow.
So are there any plans for the future direction of Scikit-Image that you'd be interested to sharing here?
So I mentioned we just released version 0.13. One was the release manager for that. So that's out the door. In fact, he pushed it out right as I was giving a tutorial, which made me a bit nervous, but that all worked out well. I think we've spoken a bit about user feedback. So, that's our most valuable input in moving the project forward. For the rest, I've been having more and more conversations with people from other tools like ImageJ, Elastic, Cell Profiler, etc. I'd really like to expand the ways in which we interact with those packages, in which we advertise those packages. There are many different workflows out there that we never see where Scikit-Image is combined with perhaps Elastic to do some segmentation. There are tools for annotation, there are tools for pre-processing, post-processing, and people who want to solve problems in the most efficient way possible, they use whatever tools they need to. But we have very little insight into that. So that's part of my mission, is to figure out, how we can improve the package, both to work with those tools and to provide the necessary set of functionality.
Yeah, in that vein, so this year we're participating in RGSOC, which is Rails Girls Summer of Code. And one of the projects that was proposed was to develop an applications gallery, which is different from our current gallery, which shows the functionality in Scikit-Image. Applications would not be limited to the set of dependencies that Scikit-Image has. So you could do something like have an application that combines Scikit-Image and Scikit-Learn together, which doesn't fit in the normal gallery. And so having more documentation as to how Scikit-Image can work well with other packages would be really good in that regard. My own bugbear, of course, continues to be n-dimensional processing, and there's still a lot of the library that doesn't work well with n-dimensional images. So I've got a pull request open now converting moments to n-dimensional data. But so I would say making sure that the API is consistent in supporting ND wherever it's possible, not just where it's been convenient in the past. And there was also this work from this guy called Adrian Sieber. We don't actually know who he is, but he built this Scikit-Image cheat sheet, and he did that using an automated script. And by using an automated script, he was able to find a lot of the inconsistencies in the API because the scripts break when they're trying to do something, and the result is something unexpected. And so he submitted an issue talking about all of the different small inconsistencies in the API. And on the road to 1.0, it would be really great to eliminate all of those and really make Scikit-Image as perfectly consistent package as possible.
I think the other story we keep hearing is that, I'd love to use Scikit-Image, but I currently use maybe OpenCV because the speed isn't quite there and I need to process 200 million images. It's funny, we've also heard this story that, we have 2 million images to process, but we don't care about letting it run overnight. So, and we prefer the API. But I think there's a huge number of people who want to use the package, but they can't sit around and wait for the result. So there's a question as to how do you deal with that situation? We don't have GPU experts, and I'm not sure we want to go that direction. We don't want to make the code even harder to access. At the moment, we're pure Python, we're Python. If you know those two, you can contribute to any part of the library. And I don't want to introduce sort of knowledge dependencies, but I do think we need to address this problem. Now, there are some very interesting players in that field, and I think the solution is going to come from optimizing Python compilers. So, the just-in-time compilers like Numba or there are so many of different packages exploring that space right now. And maybe we'll get something for free. Maybe we'll have to do something with Halide, something more custom. But I hope technologically that becomes feasible within the next year or two.
Yeah, and the Pigeon project that has recently been merged into mainline for 3.6 may help with that as well in terms of people developing custom JIT implementations that would be able to plug in specifically to things like image processing.
Yeah, we're definitely watching that space with great interest.
Absolutely.
So for anybody who wants to get in touch with either of you or follow what you're up to, I'll have you send me your preferred contact information to include in the show notes. And with that, I will move us to the picks. My pick for this week is a game that I got recently for myself and my family called Set. And it's a set of cards that have series of images that have 4 different attributes. They can be of different colors, shapes, quantity, and different sort of filling for the images. And the idea is to find a set of 3 cards that are either all the same or all different across each of those attributes. So you could have 3 cards where there are 1, 2, and 3 of the same shape that are all different colors, but all have the same filling. And so it's a very simple concept, but very sort of nefarious in terms of how the gameplay actually pans out. So it's a lot of fun. It's won a lot of Best Games awards, and it's definitely worth picking up.
I've played Set. It's a really, really awesome game.
Yeah, it's a lot of fun. Stefan, do you have any picks for us this week?
Well, yeah, since we're on the topic of games, I don't play very often, but there's a genre that kind of captivates me, the old point-and-click adventures. And I used to, when I was a kid, I played Monkey Island all the time. Recently, Ron Gilbert, funded by Kickstarter, published Thimbleweed Park, and it's just a beautifully done game. It's sort of done in the style of a 1987 adventure point-and-click. Lots of humor, very much along the veins of the old LucasArts adventure games. So lots of humor and just gorgeous graphics. When I kept up to date with the blogs as they developed the game, and there are a few very cute engagements with the community that they made during the development. Like they have a phone book that's got messages from a lot of people who back the game, for example. But the one thing out of an image processing perspective that struck me as interesting is that during the last week they had to do the artwork for Steam and for GOG, and they mentioned there that they needed to do the artwork for all the different sizes of displays. And I thought, why don't you just resize the art? And I realized, well, when you do pixel art, that's no longer an option. You actually have to redraw the graphics to fit with a specific resolution. So just magnificent to see the kinds of technical challenges that team faced in developing the game. So yeah, I've been wasting a lot of time on that this week.
And Juan, do you have any picks for us?
So the first one, it's not very current, but it's still touring, and it's Matilda the musical, and it's just fantastic. Really beautiful message. It's also a bit of a tribute to nerds all around. So I think the audience will appreciate it. So if you find it in your city soon, definitely go check it out. And the other one might be a bit unconventional. It's fitness. So if you like rowing, I think rowing is a good workout. The most popular rowing machine is the Concept D2, and I consider it to be vastly inferior to this thing called Water Rower, which uses a vat of water for resistance, and it's made of beautiful wood, and this feels really a lot nicer, a lot closer to the feeling of being on the water. So yeah, if you use the Concept Ds, have a look at Water Rower.
So I often have some of my best ideas in the shower. So this week I got a pad of Aqua Notes, and they're fantastic. You put them up against the wall, and you can make notes while you're showering. So no more of those great ideas gone. I'm sure this will bode well for the future of Scikit-Image.
That's excellent. There's this Twitter account called Bored Elon Musk. Which is all these kind of random inventions, and there was a very similar one, which was a shower glass door where if you scribbled on the steam, it would send it to your Evernote.
Nice.
So with that, I would like to thank you both for taking the time out of your day to join me and tell me more about the work you've done with Scikit-Image. It's definitely an interesting package, and one that I'm sure a lot of people will be happy to learn more about. So thank you both, and I hope you enjoy the rest of your day.
Thanks for inviting us.
Thank you very much.